Hello everyone, welcome to Miss Lee's class. Today we're going to review factors and multiples of whole numbers. So we are going to review the terms prime numbers, factors, and prime factorizations. Okay, first, prime numbers. Do you guys remember what prime numbers are? A prime number is a number that is only divisible by 1 and itself. So a prime number has two factors, 1 and itself. And factors. A factor is a number you multiply to get another number. Factor of 10 is 10, 5, 2, 1. Because 10 can divide 10, and 5 and 2 and 1, they can divide 10, right? So 10 is divisible by 10, 5, 2, and 1. So those are factors. Prime factors. So among those four, what are prime number? 5 and 2 are prime numbers. So prime factors of 10 are 2 and 5. The prime factorization, a number written as a product of its prime factors. Okay? Before we move on, so let's just think about examples of prime number. Is 1 a prime number, everyone? 1 has only one factor, so 1 is not a prime number. To become a prime number, it should have two factors. What about 2? 2 is a prime number because it has two factors, 1 and itself, 1 and 2. What about 3? 3 is a prime number. It has factors 1 and 3. What about 4? 4 has 3 factors, 1, 2, 4. 4 is not a prime number. What about 5? 5 is a prime number, 1 and 5. What about 6? 1, 2, 3, 6 has 4 factors. So it's not a prime number. 7 is a prime number. 8, not a prime number. 9, not a prime number. 10, not a prime number. What about 11? 11 is a prime number. 13 is a prime number. And 17 is a prime number. Those are prime numbers, okay? So when you do prime factorization, you're going to use only prime factors. Right. So there are a couple ways of finding the prime factorization. First, we can use factor tree. 24 is a product of 6 and 4. 6 is a product of 2 and 3, and 4 is a product of 2 and 2. So now we have only prime numbers. Those are prime factors. So we can rewrite this 2 times 2 times 2 because we have 3 2's times 3. So that is 2 cubed times 3. Factor letter. We have 24. Let's use a prime number to divide it. I'm going to use 2, becomes 12. I'm going to use 2, becomes 6. I'm going to use 2 again, becomes 3. I have another prime factor, so we're going to stop it here. And look at those factors, prime factors. You have 3 2's and 1 3. So we get the same answer. Okay? So either way, you will be able to find only one prime factorization. So you can just choose either way to find the prime factorization. Alright? Okay, are there any other factor trees or letter that can draw? Yes, we can. For example, 24. Can I use other than 6 and 4? Yes, we can use other numbers than 6 and 4. So for example, what number can I use? 12 and 2. So 24 is also a product of 12 and 2. And we cannot go any further from here because 2 is already a prime number. But we can do more here. 6 and 2. We can do more here. 3 and 2. And look at this. We still have 3 2's and 1 3. So same prime factorization. Same thing, factor 3, 24. So we can start with 3, right? Then I have 8, 2, 2, 2. So now I have 1 3 and 3 2's. So same result, same prime factorization, but we can have different factor tree and letters. Okay. Example 1. I want you to pause the video and I want you to find the factor tree of 3,300. Go ahead, everyone. Alright, have you guys tried it? Let's do it together. Factor tree, 3,300. So what I'm going to do, I'm going to do 100 and 33. And 33 becomes 3 and 11. 3 and 11 are prime numbers, prime factors. I'm just going to stop here and I can do more. So here I can do 20 and 5. And 20 becomes 4 and 5. And 4 becomes 2 and 2. And we're going to circle all the prime factors. So if you look at this tree, how many 2's do you have? 2 squared. How many 3's do you have? Only 1. How many 5's do you have? 5 squared. How many 11 do you have? 111. Okay? So this is the prime factorization of 3,300. Or we can also use factor letter. What number do you like to use? I'm just going to do 11. Then that will be 300. After that, I'm going to use 3. And that becomes 100. And then I'm going to use 5. It becomes 20. 5 again. Becomes 4. Now I can use 2. Becomes 2. Again, we have 2 2's, 2 2's, and 2 5's, and 1 3, and 1 11. Same prime factorization, right? So the result will be the same. Okay, so this is how you do prime factorization, how to find the prime factorization of a whole number. Let's move on. And we're going to learn about GCF, which is greatest common factor. So do you guys remember what the greatest common factor is? The greatest common factor of 2 or more numbers is the greatest common factor. Greatest factor the numbers have in common. So for example, when you have 24 and 60, so to find the greatest common factor, you can use 3 different methods. Okay? First method, you can just list the factors. So 24 has 1, 2, 3, 4, 6, 8, 12, 24. It has 8 factors. And 60 has many factors, 12 factors. So you can just list it and find the common factor. So there's so many common factor, right? 1, 2, 3, 4, 6, 8. 1, 2, 3, 4. Not 8. 1, 2, 6, 4, 6. Those are common factor. And 12 is a common factor. But the largest, the greatest common factor is 12. So this is the first method, but it takes a lot of time because you have to list all the factors and you have to match and you have to find the greatest common factor, right? So I don't really recommend this method. Second method, I actually really like the second method. So here, you have 24 and 60. Okay, so you're going to find the number that divides both 24 and 60. I'm going to use 4. Let's try 4. It doesn't have to be a prime number. Then if 4 is not a prime number, I'm just going to find the common factor that can divide both 24 and 60. 6, 15. And after that, I'm going to divide both number by 3. It becomes 2 and 5. Can you find any other common factor that divides 2 and 5? No. That's it. We should stop here. We cannot find any more numbers. Okay, so 4 and 3. You have 4 and 3, and you're going to multiply 4 and 3, and that becomes 12. So this is upside down birthday cake. So this is upside down birthday cake method. It looks like a birthday cake, right? Here, this is the second method. You just multiply 4 and 3 to find the greatest common factor. Okay? Third method, prime factorization. So you find the prime factorization of 24 and 60 and find the lowest power of each prime. So compare those two. What's the lowest power? 2 cubed or 2 squared? 2 squared is the lower power. What about 3 to the power 1 and 3 to the power of 1? They're the same. So we write 3 to the power of 1. And what about nothing and 5? Nothing has a lower power because nothing means 1. Like it's same as 5 to the power of 0, right? So we don't take this because nothing is lower power, right? So 2 squared times 3. Calculate it. 4 times 3. That becomes 12. So we learned 3 different methods of finding GCF. First method, list the factors. I don't really recommend this. Second method, upside down birthday cake method, letter. Okay, so here you find the common factor, divide it, and you multiply vertically. You don't multiply those two numbers, you multiply vertically, like 4 times 3. Prime factorization, you take the lower power, compare the power and take the lower power and multiply it. And that is the greatest common factor. Okay, everyone, let's move on. I want you to pause the video and I want you to try A, B, C by yourself. Go ahead, everyone. Okay, let's do example 2 together. Look at A, 45 and 54. What number do you like to use to divide? Let's do 3. It becomes 15. 18. And let's do 3 again. 5 and 6. Then 3 times 3, we multiply vertically. 3 times 3, that is 9. So 9 is GCF. 138, 198. Let's try 6. 23. And 33. Can we divide more? No, that's it. We should stop here. So GCF is 6. 12, 30, and 18. What number do you like to use? I want to try 2. I want to try 6. All right. Can we do more? No, that's it. So GCF is 6. Okay. Do you guys understand how to find the greatest common factor of 2 or more numbers? Let's move on. Now we're going to learn how to find the least common multiple, LCM. There's 3 methods as well. First method, list the multiples. So we're going to list the multiples: 36, 72, 108, 144, 180, 216, and 30, 60, 90, 120, 150, 180, 210, and find the first common multiple. That is the smallest, that is the least common multiple. Okay, so this is the smallest common multiple, and we call it LCM. So the first method is listing the multiples, but again, I don't recommend listing multiples or factors. It takes too much time and easy to make mistakes. Okay, here 36 and 60. So we're gonna do upside down birthday cake method, letter method again. Okay, what number do you like to use to divide those 2 numbers? Let's try 6. And I have 6 and 10. And let's try 2. I get 3 and 5. After that, what we're going to do is we're going to draw L. Because it's LCM, we draw L. And we're going to multiply 6 times 2 times 3 times 5. Multiply it using your calculator, and you get 180. Okay? Method 3, prime factorization. You find the prime factorization of 36 and 30, and you're gonna take the highest power of each prime. So 2 squared is higher power, right? 1 and 2. 2 squared is the higher power. 3 squared, it has 1 and 2. 3 squared is a higher power. And 5. So there's nothing, and we have 5. 5 is the higher power, so times 5. So multiply them. Multiply those 3 powers, and that becomes 180 again. Okay, do you guys understand how to find LCM? So the difference between GCF and LCM: GCF, you just multiply vertically, and LCM, you multiply L shape. Okay, all the numbers here. Okay, again, I want you to pause the video and try those 3 questions by yourself. Okay, have you guys tried that? Let's do it together. 24, 16. What number do you like to use? I'm gonna use 8. And can you do more? No, we should stop here. Then 8 times 3 times 2 is 48. So 48 is LCM. Remember, to find LCM, you multiply L shape. Next, 18, 20, and 30. Let's divide number with 2. Can you do more? No, we should stop here. But actually, to find LCM, we can do more. So if you have 9 and 10 and 15, at least 2 numbers, at least among those 3 numbers, at least 2 numbers have common factor, we do more. We go further than this. So GCF, we should stop for GCF. GCF is 2. But to find LCM, we do more. So 9 and 15 has a common factor 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. 10, we don't divide 10 because it's not divisible by 3, so we just write down 10. And everyone, 10 and 5, they have common factor. So we divide both number by 5. 10 and 5 divided by 5 is 2 and 1. 3 is not divisible by 5. You just write down 3 as it is. Now we are multiplying L shape. Okay? So LCM is 2 times 3 times 5 times 3 times 2 times 1. So using your calculator, calculate it. Then you get 180. Okay, let's try C. 12, 30, and 18. So we can do 6. After that, LCM. So can you do more here? Any two numbers have common factor? 2 and 5, no common factor. 2 and 3, no common factor. 5 and 3, no common factor. So any numbers, any two numbers don't have any common factors. So we stop here. LCM is 6 times, 2 times, 5 times, 3. That is 180 again. Alright everyone, that is it for this section. So now I want you to start doing your homework. Thanks for watching everyone.